In this lesson, we're going to look at Pythagoras in a slightly different way. What we're going to do is we're going to use Pythagoras to prove something's a right angle. This is actually called the converse of Pythagoras, but let's show you how this works. So if I wanted to prove this door had a right angle in the corner, something a joiner might want to do, then what you can do is you can actually create a right angle triangle on the corner and do measurements. So you could create a dot here and measure along, say that was 50, and measure down 65, and then measure diagonally and say that came to 82. Basically, if Pythagoras works on this, then it must be a right angle, because Pythagoras only works on a right angle. So we can do that by seeing if this hypotenuse comes to 82. So let's call that x squared, and 50 squared plus 65 squared. Because we're working out the hypotenuse, it would be an add. 50 squared is 6725. 50 squared plus 65 squared is 6725. And if you square root that answer, you get 82. So from Pythagoras, the door must be right angled. So let's look at that in a more considered approach and set our working out properly. So this is the converse of Pythagoras, and we can use Pythagoras' theorem in reverse to prove any triangle is right angled. So we've got to prove that triangle ABC is right angled. So the way to do this is to write down your sides first. So side AB is 6.8, you can see from A to B 6.8. BC is 5.1, you can see over here 5.1 from B to C, and A to C is 8.5. The next thing to do is actually to square them all. So AB squared, if you just put that into your calculator, is 46.24. BC squared is 26.01, and AC squared is equal to 72.25. So we're nearly there. Basically, if you can show that when you add this here and this here, you get this one below, then you've proven it's a right angle. AB squared plus BC squared is equal to AC squared. AC being the longest side on the triangle, so that's your hypotenuse. Okay, so in this case, AB squared plus BC squared comes to 72.5, i.e. it equals AC squared. So therefore, this must be a right angle triangle here at B, AC being the longest side. So a wee statement to finish. By the converse of Pythagoras' theorem, the triangle is right angled at B, the side opposite the longest side. And that's called the converse of Pythagoras.